Hello, eighth graders. Here is our second lesson on square roots. We're going to start by going over what we did last time, which is estimating and trying to figure out what a non-perfect square root is between. And then we're going to start doing something new called simplifying, which is kind of like reducing when we deal with fraction. So it is important that we know our perfect square roots. We've got them over here on the left side. Whoa, that's nice and big. Okay, so we've got 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100. Those are our perfect square roots. But what are we going to do if we get a number like square root of 77? So that is not one of our perfect square roots. So what we're going to do is we're going to look at our list and see what's the square root, perfect square root that is just below it. So that would be 64. So I'm going to use square root of 64. And 81 is the one above it. So then I ask myself, what times itself is 64? That is 8 times 8. What times itself is 81 is 9 times 9. So since 77 is between 64 and 81, that means if we were to calculate it out, it has to be a number between 8 and 9. And if we were to make a guess, we'd want to say, where is 77 if we laid out every number, 64, 65, 66, 67, and so on, all the way out? Is 77 at the beginning, in the middle, or at the end? So I would put this more towards the end, so I'm going to say about 8.8. Square root of 11. What is square root of 11 between? Looking over here at our perfect square roots, it is between 9 and 16. So I'll put 9 on this side and I'll put 16 on this side. I'll ask myself, what makes 9, which is 3 times 3? What makes 16 is 4 times 4. So square root of 11 is somewhere between 3 and 4. Okay, if I think of all the numbers written out from 9 to 16, where is 11? It is closer to the 9, so I want a low estimate here, like 3.2. Square root of 22. Take a moment and see where you think that lies on our perfect squares list. Square root of 22 would be right here between 16 and 25. What times itself is 16 is 4 times 4. 25 is 5 times 5. So this is between 4 and 5. Is it closer to the 16, closer to the 25, or right in the middle? This is closer to the 25, so we want a decimal that is close to 5, like 4.8. Now, I'm not going to worry about whether it's 4.7 or 4.8. I just want you to be confident that you can say whether it's at the beginning, the middle, or the end. Lastly, square root of 44. So where's square root of 44 on our list? Right there in the middle, between 36 and 49. So that is going to be between 6 and 7. And if I had to make a guess, it is closer to the 7, so maybe like 6.7. Okay, so lesson 4 is about simplifying square roots. What does, let me get my highlighter here, what does square root of 16 equal? Well, it is 4. And please notice that 4 times 4 is 16, so they're kind of like opposites of each other. So another way to write square root of 16 is square root of 4 times 4. What does square root of 36 equal? That is 6 times 6. What does 6 times 6 equals? That is 36, so they're like opposites of each other. So please notice that the square root of 36 is the same as 6 times 6. I'm not going to use those other two examples there. We can use this idea of writing it out as a multiplication. So rewrite square root of 20 using at least one perfect square. So I'm going to think about what my perfect squares are. They are 4, 9, 16, 25. Well, I don't have to go really any bigger because I'm trying to get something that makes 20. So as you look at this list, do any of these numbers multiply to make 20? And sure, it is 4 times 5. Okay, now why did I put the 4 as a red number there? Is because it is a perfect square root. So this piece of it right here, the square root of 4, I can do. Square root of 4 is 2. Now this one, this 5, is not a perfect square. And it's still inside the symbol there, so it's still going to stay inside there, forever alone inside there, the 5. So I would read this as 2 square root of 5, or 2 radical 5 is another way you might hear it said. Okay, our second one, square root of 28. That is not one of my perfect squares. So I'm going to see if any of my perfect squares go into it. Again, we can just look at these 4 because it's a nice small number, 28. Do any of these numbers multiply to make 28? 4 again. So 4 times 7. So that red 4 is perfect, and I can pull it out. That square root of 4 is going to become a 2. That 7 is not perfect, so it's going to have to stay inside there. Okay, let's do 50. Square root of 50. And then we don't have to do 28 because we just did that one. So I want to get my list of perfect squares. What are they? They are 4, 9, 16, 25, 36, 49, and I don't have to do the next one because it's bigger than my number, which is 50. So do any of those on that list make 50? Okay, how about 25 times 2? Square root of 25 is red because that is a perfect square. What makes 25 is 5. So I could pull that one out. And then this 2 is going to stay inside there. So this is like reducing. I took this big square root of 50 and I made it into something smaller, simpler. A whole 5 and a square root of 2. Being multiplied, by the way. Okay, so 18, 44, 169, and 75. Let's get our perfect squares. Please notice that I'm writing them down each time, and I highly recommend you do that when you're working on the homework. So have a list where we use 2 times 2, 3 times 3, 4 times 4, 5 times 5, 36, 49, 64, 81, 100, and we'll come back if we need to go any higher than that. Okay, so what makes 18? Square root of 18 is the same as what thing over here multiplied? How about 9 times 2? The square root of 9 is perfect, so I can do it. What makes 9 is 3 times 3, and then that 2 is not perfect, so it's going to have to stay inside. What makes 44? So I'm going to look at my list and see if I've got any red numbers that can divide into, or yeah, sure, divide into it, or multiply with something else to make 44. Either way to say it. So here is 4 times 11. The square root of 4 is perfect. What makes 4? That is 2 times 2, and that 11 is going to be forever alone inside the square root. So 2 radical 11 is our answer. Now the next one's interesting. It is square root of 169. This kind of brings up the point that you don't have to do this if it works. 169 is perfect. Does anybody happen to know what times itself gives you 169? It is 13. And I'm done. That's all. Okay, last one, square root of 75. What multiplies to make 75 from our list of red numbers that are perfect squares over here? That would be 3/4, 25 times 3. Okay, square root of 25 is perfect, so I can do that. That is going to come out as a 5, a big regular 5, and the 3 will still be inside the square root. We're going to do one more triangle like we did the other day. Remembering our Pythagorean theorem, we put our A on our smallest side, our B on our middle side, and our C has to be the longest side across from the right angle. I'm putting it into a squared plus b squared equals c squared. I'm going to plug these numbers in. So I'm going to put in a 3. I'm going to put in the 8. I'm going to do that 3 times 3, 8 times 8. Next thing I see is the adding sign, so I'm going to add those together. And then the opposite of the square is the square root, so I'm going to square root both sides. So my answer is the square root of 73. That is not perfect, so I can't just say the answer is this. I could do like we did at the beginning of this unit and the beginning of this lesson where I said what is it between. So let's just do that real quick. Square root of 73 would be between 64 and 81, so it's somewhere between 8 and 9. I could make a guess estimate based on where it is in there, and that one kind of feels like it's right in the middle, so I'm going to guess approximately 8.5. And then from today's new lesson here, do any of my perfects go into 73? So the perfects I'm thinking of are 4, 9, 16, 25, 36, 49, 64. Do any of those go into 73? They don't. So we will not be able to do that simplifying every single time. We'll just be able to do it when one of those numbers divides in. So if I'm asking you to do it, it will have something that goes into it. If it just comes up in a triangle problem like this, most likely it's not going to have a perfect square that divides into it, but you're going to want to look at the directions, and the directions in this case said simplify. So if we could, we should be doing that instead of just typing it in our calculator. Okay, so please feel free to watch this video again if you need to. I'm going to be having Monday office hours, which means I will be sitting in a Zoom meeting available to you for help on Mondays. Also, Mrs. Reed and Mrs. Bernecki are having office hours, so you can ask them for help. I'm going to be posting these videos Tuesdays and Thursdays, and we will do something fun on Fridays if you'd like to join me. Tonight's homework is the 7.3. Hope you guys are all doing well and have a good night.